continuity and discontinuity. Now we also need to talk about increasing and decreasing behavior, and this is very similar to the idea of slope. It's not slope. Slope is only for linear equations. But when we talk about increasing and decreasing behavior for other types of graphs, we talk about it on a set interval. So in any interval, if we have a positive change in x, so the x is going from, say, 1 to 4, so we're going left to right, that positive change results in a positive change in our f of x. So our graph would be similar to this. Draw a graph down here, and we can see on any interval that we have here that I can choose 2 points. So let me choose a point here. Let's call this lowercase a, and over here we'll call it a uppercase a. We see that as x increases, the y values also increase. So if I were to draw, and I'll do it in red here, a line through those 2 points, we would have a positive slope. But on this interval, anywhere in this interval here, it is always going to have that positive slope. That's why it's increasing. Now if we're talking about decreasing, what do you think would be the difference? Well, we're still going to talk about a positive change in x. So as we're going from a, lowercase a, to capital A, but instead of it increasing, instead of having a positive change, we're going to have a negative change. So we can take our graph and really flip it upside down and see that at these 2 points with a positive change in x, so positive delta x, we'll have a negative change, oops, that's an a, it should be a delta, meaning change of f of x. So it will be going down. We will have a negative change. And again, if I draw a line as best I can through these 2 points, you can see that this is going to have a negative slope, and at any point on this graph or in this interval, it will be going negatively. It will have a negative slope for any 2 points. The last one is a constant interval. Again, we'll talk about positive change in terms of x. But in this case, we've talked about positive change in f of x and negative change in f of x. Well, what's left? The last thing that we're left with is that there is no change, or what we also say a zero change in f of x. We see this in equations like y equals 2. Okay, it's a constant function. It is just a flat line. So if I pick my a and my a, capital A and lowercase a, I see that there is no change, that the slope of this line is 0. So far I've drawn increasing function, decreasing function, and a constant function, something that is always that type throughout the function. But we can actually have a combination. It does not need to just be one. So I can have a part that is decreasing, a section that is constant, and a section that is increasing. So we have at our specific locations, our specific spots, we'll call it A and A. Sometimes it is going to be decreasing, sometimes it will be constant, and sometimes it will be increasing. It's actually more interesting when you get things like that. It's really boring if it's only one or the other. We will be estimating when it is increasing, decreasing, or constant based on its graph. If it's given to you, you'll be estimating the points, or on a calculator, we can estimate it. We can graph it on the graph from the calculator.